Okay, we got one more question today for the problem set 10. And I'm just going to go over it pretty quickly because I'm running out of time. But it's from problem set 10, and it's question number 10 about um, the United States repeated interactions with Russia, I think. It's with the USSR. We're going old school today. So with this, so question A is given the trade-offs, identify the Nash equilibrium. So remember identifying the Nash equilibrium. First let's look at the US first. The USA only looks at the first option. And the USA, this is, when you're looking at the Nash equilibrium, remember you cannot change the other person's decision. So assuming that the USSR is waiting, which means that the USA can only move from here to here, is it worth it to attack? And yeah, it is, because it's worth it to the US to attack. So since we know that the US wouldn't stay here, we'll do them blue, and that is not Nash. So this could still be a Nash equilibrium. So let's look at the USSR here. And remembering, this is assuming the US is attacking. The USSR can't change what the US does, but they can change what they do. So if you're assuming that the US is attacking, would the USSR choose to wait or attack? And it looks like the USSR would choose to attack. So since the USSR wouldn't choose to stay in this position, we know it's not Nash. Now let's check out this one. Let's check out first the USSR. We know they're going to be here because they wouldn't be here. So let's look at USA. Would the USA choose, and remember, we're assuming the USSR is attacking. The USA can't change the USSR's choice. So the USA can only move from here to here. And so 0 to 1. So they would definitely stay here and attack. And then this other one is not Nash. So the Nash equilibrium is attack, attack. Yep. So if you know that waiting, this next part says, if you know that waiting gives you the chance to earn 2 UDLs every year for the next 10 years, does it change? It changes the payoffs, and then it asks you to fill in the matrix again. So you're gonna have to change things here. And sorry, I'm looking at the slides because I'm just making sure I'm doing this right. Okay, so okay, so you gain 2 UDLs for every 10 years. So you're happiest if only you attack, but you'd rather both waited than both attack. If you play it once, you both attack. If you know that waiting gives you the chance to earn 2 UDLs for the next 10 years, it changes the payoffs. So with this case, we know that waiting, if we both wait, it's going to be like 2 times 10. Because each year you wait, you gain 2 UDLs. And so waiting actually ends up being 2020. And then you still have the 3, 0 and the 1, 1. Because, I mean, if one of you attacks, that means you're not waiting. And so you don't get any benefit for waiting if the other person doesn't wait. You only get benefit for waiting if you both wait. Because if you wait but the other person doesn't, you get bonus. So no real benefit. But you earn 2 utils every year for waiting, and you've waited 10 years. And so let's talk about this new setup. So in this case, if we start here with the US, they can choose to wait or attack, and obviously 20 is better than 3, so they choose to wait. So we know this is not Nash. And the USSR, they could choose to attack or wait, but 20 is greater than 10 again, and so we know that the USSR would stay and wait. And then here with attack, if we're looking just at the US, it's better for the US to attack. If we're looking at Russia, it's better for Russia to attack. And so actually this is a Nash equilibrium as well. So because waiting in this case, this is kind of like pretty similar. It's a pretty similar problem to the prisoner's dilemma, like this one here. But this situation almost gives like extra benefit to staying silent, or to or in this case to waiting, that makes it valuable enough to not attack. That adds another Nash equilibrium. The attack is still a Nash equilibrium, but because waiting has increased in value because of the added utils you get for each year you wait, waiting is also a Nash equilibrium. So you can do both of those. So